I'd like to welcome everyone to Microdesk's AEC Collection Hacks for Engineers. Today, we're going to be talking about the new Autodesk Architecture, Engineering, and Construction Collection. We'll be focusing on engineering disciplines, and we'll discuss some of the lesser-known software included and how they can potentially resolve some common workflow issues. But before we get ahead of ourselves, please allow me a moment to more comprehensively introduce my company and myself. Microdesk is a consulting firm that focuses on the architecture, engineering, construction, and facility operation industry. We've been providing services to our clients for over 20 years and have 13 locations across the United States and one in the United Kingdom. Our staff includes over 150 consultants and developers who specialize in the software and workflows relevant to our industry, and every one of them has had previous experience within the industries we serve. The services that our staff provides includes building information modeling services, enterprise strategy and workflow assessments, technology management, mentoring, and support, as well as application development. My name is Greg DeLiso, and I am a Strategic Implementation Manager here with Microdesk, and I specialize in BIM workflows and implementing BIM technologies. Today, we're going to be talking about the new Autodesk AEC Collection. We will briefly review the contents of this package, the tools that are useful for each design discipline, and which tools are considered to be the primary products. Then we'll cover how a few select pieces of software per discipline can tie into those flagship products and enhance current workflows. We'll review some potential challenges and how the included software can help your firm address them. And for a few, we might review some real-world projects and how they successfully implemented the technology. As we go, if anyone has a question, type it into the GoToWebinar interface, and I'll try to work any answers into the presentation if it fits. Otherwise, we can address what we have time for at the end. To help me get a better understanding of who we have with us today, please take the time to answer a few quick survey questions. And just allow me to get that fired up. So, first, what part of the building project lifecycle is your firm primarily serving, either design or construction? All right, thank you. Next, what is your design discipline? Thank you again. And lastly, how experienced is your firm with building information modeling, or BIM? Perfect, thank you. So we have a pretty diverse group here today with all sorts of backgrounds and experience levels. Hopefully, this presentation will address a little bit of everything for each of you. So let's take a look at what's included in your AEC collection. We have 22 standalone products, 1 major plugin, and 25 gigabytes of cloud storage. Equally important is the value that all of this brings. Even if your firm is only using 2 of these programs, there is a huge cost savings over purchasing them individually. These products offer comprehensive solutions across the entire project design lifecycle, from project inception through planning and design, analysis, documentation, and fabrication and installation. We won't be spending too much time with the software listed here specifically, but it's important to understand that the products shown, Revit, AutoCAD, Navisworks, and Civil 3D, are the foundation of any Autodesk workflow for AECO professionals. All of the products that we will be reviewing today somehow tie into one or more of these pieces of software. If you aren't currently familiar with these products, I highly recommend you take some time to become acquainted, as these are some of the most robust platforms available to our industry for modeling, documenting, and coordinating projects. Often, these products allow you to streamline your projects from design all the way through installation. The whole idea behind BIM is to constantly refine our stream of information, including both data and geometry, to reduce rework or remodeling efforts, increase the accuracy and efficiency of our designs, and allow us to fully collaborate and communicate design work with other project stakeholders. We can start by digging into some useful programs applicable to anyone within the AEC industry. AutoCAD raster design has been around for a while and allows us to convert raster or pixel images into vector DWG format. If you've ever had to trace a set of scanned construction documents, you'll quickly understand how this can be valuable. DYNAMO Studio provides us with a standalone environment to develop and review computational design scripts in a visual programming environment. It may sound challenging, but it can be easy as connecting the dots. These scripts can be developed to automate previously repetitive or challenging tasks at the click of a button. Today, we're going to look a little bit more at what DYNAMO can offer. Format Pro allows us to explore conceptual parametric designs and preliminary energy analysis while also allowing us to collaborate with the rest of the team. Think of it like a cloud-based SketchUp with some cool additional features. Recap Pro allows us to create accurate 3D models from reality capture and laser scanning tools. We'll also take a look at Recap Next in a moment. Revit Live is a visualization tool for 3D models, typically for VR immersion. 3ds Max is both a powerful rendering and modeling simulation tool. And lastly, as mentioned before, all AEC Collection subscriptions come with 25 gigabytes of cloud storage. One program that everyone who owns the AEC Collection should understand is Recap Pro, which is a crucial part of the scan-to-BIM workflow. Whether you need to track existing conditions or verify as-built installation, Recap Pro is the go-to tool to review project information from the real world. Its features include the ability to capture information, site and building conditions documented by reality capture devices such as UAVs, drones, and laser scanners can be brought into Recap for review and modification. It can refine data. This incredibly user-friendly software has been designed for use by someone with no experience, and one-click automatic workflows can do powerful tasks like scan registration, which stitches multiple scans together into one point cloud, and intelligent cleanup services to remove unwanted noise. Lastly, it can be used to create new intelligent models, as Recap integrates with all of the Flagship products mentioned earlier. How often have you worked on an existing conditions or renovation project and had documentation that did not correspond to actual field conditions? And how much time was spent afterwards field surveying the required information? With Recap, we can utilize real 3D data from the field to inform better design decisions and reduce the overall surveying effort. Time is money, and the scan-to-BIM workflow can save your team lots of it by providing accurate contextual information. We can use our scans to define our project environment and investigate unique conditions like the canopy in the image here. We can then use the scan to review any design decisions we've made against a realistic set of boundaries. And in doing so, we've helped ourselves to discover and resolve potential problems before they ever hit the job site, reducing costly rework and reducing potential change orders during construction. As mentioned earlier, Recap integrates with many of the products contained in the AEC Collection. Importing a Recap model into Revit allows us to plan and design building models, extract relevant information from the laser scan, and visually see the contextual conditions present in our project. Recap also integrates with Civil 3D, allowing us to do things like reducing the overall surveying effort by generating accurate topography from site imagery and scans. And it also integrates with Infraworks, where the point cloud can be used to extract information like bare earth terrain, vertical point features like trees or light poles, and linear features such as roadways, which can then be used to refine existing surfaces. The following project is a great example of the scan-to-BIM workflow and the success that it can provide. The Velsertunnel in Norway is an existing railway and motorway tunnel that serves approximately 65,000 vehicles per day. The renovations took 9 months and shut the tunnel down during construction. Numerous upgrades were planned for the tunnel, including a modified clearance profile and the addition of state-of-the-art CCTV, fire protection equipment, traffic control systems, ventilation systems, and more. In addition to all the additions and requirements to adhere to more modern codes, an additional challenge was that portions of the facility belonged to various national monuments and could not be modified. The existing condition scan in Recap Pro was used to develop a feasibility study. Part of that image is shown on the top right, and to develop the initial conceptual design strategy. Based on the scan, they were able to extract brake lines in the tunnel and import this into Civil 3D, directly attaching subassemblies to generate the existing tunnel model. Based on automated tools in Civil 3D and Revit, they were then able to generate construction drawings directly from the model. They took all of these models and then federated them within Navisworks Manage to resolve potential constructability problems with clash detection before they ever reached the field, reducing potential delays. And lastly, they used the models for 4D analysis in Navisworks Manage to ensure that there would be no scheduling conflicts during construction. In the end, the owner ended up with an optimized state-of-the-art facility that didn't break the bank or their schedules with unforeseen costs and delays. Next, let's take a look at DYNAMO Studio, Autodesk's incredibly useful visual programming platform. The BIM process starts at the earliest stages of design and is meant to carry information seamlessly through to further stages of development, avoiding the need for remodeling. With DYNAMO, we can rapidly iterate on an architect's design model, allowing teams to explore parametric conceptual designs, create faster designs of complex structures or systems, optimize building system design, automate repetitive tasks, and improve design accuracy. DYNAMO Studio, I should mention, is a standalone program packaged with the AEC Collection that allows us to review our scripts outside of programs like Revit, while the DYNAMO plugin for Revit and Advance Steel, and also Navisworks, allows us to use and manipulate Revit data. Perhaps we have received an architect's preliminary model and would like to quickly develop a variety of schemes to explore various conditions. DYNAMO allows us to select aspects of the architectural model that we'd like to focus on and convert them to schematic elements such as slabs, beams, and columns. Once the selection process is complete, you can experiment with column and beam placements before finally settling on an idea that can easily be converted to a structural model where you can then add further design detail in Revit. And then modifying the design is as easy as you can see here, where we're adjusting an input slider. Once we're satisfied with the results, we can bring them back into Revit for documentation. But before we do that, here's another example of how, by manipulating a few of these input sliders, we can significantly modify our geometry. Then with a little more code, we can bring it into Revit. And here we go with the final product inside of Revit. It's worth mentioning that DYNAMO is not only for developing geometry. If you've ever run into a situation where you need to rename or renumber a sequence of elements, apply a parameter value to large quantities of elements, export specific information to another program such as Excel, then you've already experienced some of the issues that DYNAMO can help resolve. These examples may have focused on structural engineers, but anyone within the AEC industry can make use of this tool and expedite tasks. And due to the nature of visual programming, DYNAMO is easy to use. As we can see here, each box is a self-contained command that can contain inputs, outputs, or both. If we follow the image displayed on screen, on the left, we have inputs represented by number sliders that can dynamically adjust the values being output, which are then connected to commands such as point by coordinates, which is looking to receive an X, Y, and Z input, which then outputs one or more point locations in the model space. We can chain these inputs, outputs, and commands by drawing lines between them, and in doing so, we are continually developing a script that can be adjusted and executed as needed. That same combination of commands, inputs, and outputs can also be replicated using either the design script or Python programming languages. Besides previously discussed software, let's talk about some of the other AEC products relevant to civil engineers. Infraworks is a powerful planning and design program that allows you to rapidly convey preliminary design intent in a real-world contextual environment. We'll take a closer look at what Infraworks can do in a moment. AutoCAD Plant 3D is a somewhat niche tool for large infrastructure projects, such as wastewater treatment plants, that can be utilized by both civil and MEP engineers to generate efficient piping and instrumentation diagrams, 3D models, and 2D drawings of large facilities. AutoCAD Map 3D provides us with the ability to access CAD and GIS data to support the planning, design, and data management of site development projects. Lastly, Vehicle Tracking can assist us in streamlining roadway and parking lot planning and design using swept path analysis and its large library of vehicles. We'll also take a brief look at this in conjunction with Infraworks. I should also note that parts of both Map 3D and Vehicle Tracking have been integrated into the Civil 3D user interface. So it's possible that you may have already used some of their features through regular Civil 3D usage. Using Recap, we've briefly discussed how we can improve the surveying effort and extract information from real-world data. Next, we'll turn our attention to improving the planning and design process for site development. Infraworks allows us to aggregate data from traditional surveys, laser scans, LiDAR, GIS, and satellite imagery to evaluate design alternatives, perform analysis to optimize our designs, and communicate our design intent with videos and renderings to other project stakeholders. We can easily generate the site shown, which includes buildings, trees, water, roads, elevation profile, and the Bing Maps imagery from Infraworks' built-in model builder to transition to something as seen here. Big jobs can be difficult and time-consuming to develop, which is why our tools need to be fast, easy to use, and tie into future software platforms. So how can we manage that? How can we get to the results as shown in the previous image? The answer lies in how Infraworks allows us to quickly evaluate multiple design options and perform actions such as defining a site or establishing a building pad simply by tracing out a geometry when using the tool, doing the same thing to develop a conceptual building layout, establishing road access and parking lots, and placing detention ponds, trees, and other site assets. It can also be used for large-scale land development schemes due to the intuitive model-based design. It's simple to use the provided selecting tools to define the roadway as seen here on the right. We can then sketch our path from a connecting road to generate our roadway, modify the horizontal and vertical profile of our roads, which is as simple as selecting the grips and moving them up and down for both horizontal and vertical profiles, developing and importing parcel layouts from Civil 3D to then manipulate in Infraworks, and then to apply material and color for ease of communication. This process allows for a back and forth between Civil 3D and Infraworks, enabling us to refine and enhance our project development cycle. Infraworks is an incredible tool that has so much more to offer than what I've shown just now. It can even handle things like preliminary road design, bridge design, and drainage designs. It can even be used as a communication tool to generate flyover animations, or in conjunction with vehicle tracking, which is exceptionally easy to use. Simply by drawing a line and tracing a path, we can generate parking layouts. And vehicle tracking uses its library of code data and vehicle information to streamline not only your parking lot design process, but also roundabouts and other paths of travel for steered vehicles. So here we can see our vehicle tracking parking lot imported into Infraworks. Here we can see some swept path analysis after having picked a specific vehicle as it moves around the roundabout. And again, the roundabout is as easy to move as what we've seen for roadways by simply picking lines and dragging grips. Here's more swept path analysis of a large truck on a roadway. And all of this results in a workflow that's better suited to getting our designs out the door without all the unnecessary rework. Once again, besides this previously discussed software, let's talk about some other relevant products for MEP engineers. AutoCAD Electrical and AutoCAD MEP are likely well known to our MEP attendees, and these platforms contain a variety of tools and content to assist in the specifics of MEP system planning, design, modeling, and documentation to enhance existing AutoCAD functionality. AutoCAD Plant 3D we've briefly reviewed before and again is useful for larger infrastructure projects. Insight is a cloud-based service that further empowers designers to analyze building performance with advanced simulations. And we're going to take a look at Insight and what it has to offer in a moment. And Fabrication MEP, which allows designers to use manufacturer-specific content to create more accurate models, develop and analyze cost estimates, and automate or optimize the development of fabrication drawings and layouts for the plasma cutting of sheet metal. It can also be integrated with Revit to provide a similar content library for use in your BIM model development. So in addition to modeling and documentation tools, the AEC Collection comes with analytical software, such as access to the cloud-based Insight platform. This platform makes it easier than ever to optimize building performance for factors like ventilation, air quality, and thermal comfort at the earliest stages of the design. This powerful analysis tool uses simulation engines for whole building analysis, including energy, cooling, heating, daylighting, and solar radiation studies to allow designers the ability to monitor performance changes throughout the course of the project. In the past, generating this information could be very time-consuming and was often a detailed and tedious process left in the hands of experienced and valuable staff members. But now, Revit includes direct access to building performance analysis using Insight. With the push of a button, you can send your Revit model to the cloud for analysis, allowing for rapid iteration using Autodesk's extensive cloud processing power. Results are quickly returned in a visual, easy-to-read format, making it easy to identify opportunities to improve your design. You can even see how the data was calculated so that you can have full confidence in your designs. And we'll take a look at this process right now. It all starts with the building model, either from Revit or Formit, which if you remember is also included in the AEC Collection, and the physical site location information from those platforms. You need to tell Insight where this project is located for accurate solar design. We can then use the Generate or Generate Insight button in the Analysis tab of Revit to immediately send our model to the analysis environment, where we can review information such as lighting efficiency, HVAC, photovoltaics, peak heating or cooling, and more. This information can be used to develop multiple design options and help determine the best solution for building performance. In these menus, you can adjust the limits of variables that affect energy usage, as seen here. So simply by selecting lighting efficiency, we can see the various values. And on the bottom, we can specify the limits of those parameters. So for example, we can define that a building is not in operation 24 hours a day, but maybe from 6 a.m. to 6 p.m. That's all defined right here by clicking and dragging in that window on the bottom. So again, this information can be used to develop multiple design options, and it can help you determine the best solution for building performance. After comparison, we can then develop a load calculation summary to review and export our results. Autodesk analytical software such as Insight and plugins like Lighting Analysis for Revit make it easier to generate buildings that perform better. So we're going to finish up today's webinar with some additional products that are relevant to structural engineers. Advance Steel is a detailing platform built on top of AutoCAD, allowing us to develop fabrication quality models. Advance Steel offers us high-precision modeling of steel connections and expedited shop drawing development based on the model, reducing rework. We're going to take a closer look at Advance Steel in a moment. Robot Structural Analysis Professional is an analysis platform that can round-trip information to and from Revit and allows us to test the effects of structural loads or verify code compliance on our models. Structural Bridge Design is an integrated software solution that provides tools for the traffic load optimization, analysis, and code checking of small to medium span bridges. Once your design has been completed using tools like the Bridge Section Designer and Girder Designer, you can easily export the results to a report, enabling you to understand the calculations performed, and it can include cross-references to the code in practice. Structural Analysis for Revit is a cloud-based analysis platform similar to Insight, which is integrated as a plugin within Revit that can allow us to visualize and explore the calculated results. It offers static and gravity analysis as well as reports for the results that it finds. The AEC Collection contains products that can support the entire project design lifecycle. We've gone from project conception and site development to modeling and analysis, and now's the time to talk about fabrication. Just like with analysis, in the past, developing fabrication quality information required a lot of redrafting, consuming time and money. And on the design side, the same can be said for developing steel connections. We can solve both of these problems with the power of Advance Steel, a structural steel detailing software that is easy to use and incredibly comprehensive. It helps users accelerate their detailing workflows and with 3D modeling tools that improve accuracy and reduce the time from design to fabrication, and soon we'll see how. Advance Steel also has seamless bidirectional integration and model synchronization with Autodesk Revit. This allows you to import 3D design models from the structural engineer as the starting point for your detailing effort. In addition, with steel connections for Revit, all of Advance Steel's connections have been integrated within the program, which allows engineers to bring their models to LOD 350, streamlining detailing. Advance Steel also integrates with DYNAMO, offering us the same powerful tools that have previously been discussed in conjunction with Revit. And we can see how we can apply various parameters such as the actual section shape here in DYNAMO with Advance Steel. We can even streamline the design and review of steel connections by working in a common BIM environment. Again, with over 130 steel connections matching up between Revit and Advance Steel, it's now possible to link connection design intent to the steel connections associated with assemblies. This helps the design evolve into the detailing process with less data loss. We can use the built-in tools inside of the Revit plugin to fully customize each connection by defining things like the steel shape and size from the AISC manual, adjusting values such as offsets and number of bolts, so that we can not only represent these conditions in 3 dimensions to later develop coordinated drawings, but also to review the connection for code compliance, and then generate reports with documented calculations and results so that you can be confident with the outcome. Afterwards, the connection can then be approved, rejected, or given some other status within the model to communicate more effectively with the team, as seen in this parameter here. In addition to interoperability between Advance Steel and Revit, Autodesk has technology partners like Idea Statica and Reset Technologies to offer other solutions that are integrated on top of both Revit and Advance Steel. Moving from Revit, exporting into Advance Steel is simple. We simply navigate to the Add-ins tab and use the export option inside of the Advanced Steel extension. And then, in Advanced Steel, we can import the file just as easily from the Export and Import tab, resulting in a fully recreated model inside of Advanced Steel without all of the rework. Once inside of Advanced Steel, the steel connections from Revit and assemblies automatically compile. Advanced Steel knows from these Revit elements what they're meant to be, where we can then continue to refine each assembly through a variety of options, such as material, overall size, shape, and spacing, connection types, and more, until we're satisfied with the results. With another click of a button, Advanced Steel is able to generate shop drawings based on predefined templates. All that remains is for the detailer to set their numbering settings and number their model. Advanced Steel has an incredibly powerful shop drawing engine which allows a large range of customization and automation features. This enables steel detailers to match the steel fabricator's preferences for showing things like dimensions, marks, title blocks, and bill of material layouts. Lastly, besides easy access to important data like bills of materials and saw cut information, Advanced Steel can help automate the production of NC files for use with CNC machines and the development of XML files to help drive welding robots. All of this results in a more streamlined workflow dedicated to efficient transfer information from the design process through shop drawing development, review, and fabrication.